First of all, thank you so much for being here today or watching this later on. I want to introduce to you my particular story for getting ready for Declarative UIs with Unidirectional Data Flow using Kotlin Coroutines. And thank you so much for calling Stuttgart for having me today. First of all, let me introduce myself. I am Raúl Hernández López. I work as a software engineer for Twitter for the last few years and working in different future work and in the London time zone. If you want to follow me, that's my handle. And also you can see the code snippets that you'd see during this presentation in my GitFile user, also in GIST, into that one that I have right there, top right. And let's go to the important bits of today, basically the agenda. I will start introducing, first of all, a use case where everything hopefully will make sense to you. Then I'll start analyzing and assessing architecture because for me, the main and important point of today's talk is basically the fact that you can start using Unidirectional Data Flow in any particular architecture. You don't really have to be attached to any particular one. Then I'll mention some implementation details on my particular use case, some lessons learned that were important for me, and why compose can be a choice of matter that matters to you on Android. And finally, of course, some next steps. So next slide. This is actually the use case. You can see that I am trying to type something here. And meanwhile I am typing, then you can see a loader, I failed, so you can see the empty results text with this particular thing that I failed until it's completed, and then retrieve some successful results. And then I can click to one of those items and then see the detail of this cheat that I was looking for. That's basically the sample app, nothing else. But now let's see what do we have for the architecture. So then with that architecture, hopefully we can start adopting an existing architecture on that. So first of all, the data layer, which is basically a repository that is composed by the network data source and a database data source. This is basically the one that is being managed by the data layer with the different results that are going to be passed to the next layer. Then we have the business layer, that is the use case, which transforms anything that comes from this repository and then passing this back by means of callbacks. Then basically the use case is going to do any business logic that needs to be done before passing to the next layer. And we are passing initially with callbacks those results back. Then the presenter is going to be the one executing that, passing the results back from the use case to the presenter and then to the view. And then the view is going to be the one receiving this new data and then rendering those results on a screen. Basically, by the user typing a particular query of interest, we'll have all of this. As you can notice, both the presenter and the view were in Java. So this is basically a hybrid application with Java and Kotlin. And basically, the system interaction is quite simple. Basically, we start a search for a query, and then we react to different queries, and then we start this query. Basically, I extracted anything that is related to the logic for the view, and I created this new view delegate that is going to be having this particular stuff. But now let's see what the different coroutines that we have in there. For instance, I have the network data source and the database data source that basically going to pass by me as a spam function some results, basically as a spam function because for me are one-shot operations only. Then the repository, which is going to be emitting different flows, calling flows, and those are going to be passed back by means of those results to the next layer. The use case, which is going to be basically collecting those flows and then doing whatever it needs to be done. And that's basically it. But how do we get ready for declarative UIs, which probably going to be the main question that we are trying to figure out today. So basically, we have those callbacks over here. But initially, what we need to do is analyzing if those callbacks are any good for us or not, because maybe we don't need to remove them at all. And for that, we're going to see if those disadvantages are bad enough to say we want to get rid of them. First of all, lack of readability. We have here our friend, our colleague invited for today's party, Ryu from Street Fighter. Probably you are familiar with that if you are as old as me. And this created an Ayuken that basically created a lot of indentation with many callbacks and more callbacks, inner callbacks into those callbacks. So basically here, as you can see, there is not evidence about where you are and where you are going to go. And this is even harder when you have a bug and you want to fix it. So it's not only a matter of reliability, but also predictability. So callbacks into callbacks, also called callback hell, is probably an anti-pattern that you want to restrict and not use when it's possible. So basically, callbacks break a referential transparency principle that is very interesting and comes from the functional programming world. Basically, it means the ability to make larger functions out of smaller ones through composition and produce always the same output for a given input. So that means that if you are trying to achieve something for a particular input, let's say an integer with a 3 as an input, maybe we are going to only have an addition to that, and it's a 3 as this addition. So if we have 3 as the input, we are adding 3. It should be always having this output as a 6. So that's what it means. Basically, we don't want to break this principle in order to have predictability of results. But then if we use callbacks, which consequences have for this reference and transparency principle being broken, basically? So first of all, we have a lack of a return value in callbacks. We don't have a return value. We just have other input parameters that could be declared as the input for the next callback. And then every next callback, we're gonna have another input, which is gonna be the other callback. So this is actually very difficult to actually predict and to test, indeed. So results can mutate with callbacks, and that means lack of determinism. Because if can mutate, we don't really have a way to predict when anything is going to start and is going to finish. And that's a problem, really, when we are trying to make a system reliable. But are there any better alternatives to callbacks, really? So if we think, for instance, in Stateflow always returns the latest value when is different. And also, the results are immutable with Stateflow, which means that because Stateflow in the contract is the interface of a mutable Stateflow per se, then Stateflow is going to be read-only. So anything that we emit when we create a mutable Stateflow by means of the interface Stateflow is going to be immutable by default. And this is something we preferably want to. And that means that it's going to be deterministic by default, because if we only change Stateflow in one place and we are going to read it anywhere else, then we are making sure that our systems are deterministic. So basically, maybe changing this from the use case to the placenta, extending that to the view through the different stakeholders. Then, of course, we need to also collect Stateflow. And that means that we need to collect it into a Kotlin class. Because for hybrid projects, if we use Java files, you cannot really collect a coroutine if you don't have a Kotlin file. So you're going to need to have a helper, as I did with the Stateflow handler. But now let's go to adopt Unidirectional Data Flow and then see what's important here. First of all, what does it mean? One-way data flow. We have only one way to start and only one way to finish. And this is always the loop that is going to be happening. This is a good example of that. We have our UI that intends an action. This action transforms the different results into a state, and this state is going to be rendered as a UI. So always we are going to have this cycle. As a UI, going to intend a new action. This is going to be transformed into a new state, and this new state going to represent a new UI. And with that, you are going to always have a relationship of one state, one UI. If you want a new state, you will have a new UI. But if you want a new UI, you will need a new state. And with that, you wouldn't have side effects. You will always have a unit that's going to be represented as a UI. If we think in the different entities, basically this is the diagram going to the action. So I use my imperative UI, intending an action, then my view delegate triggers this action. The presenter executes the action to a use case, let's imagine the use case returns the proper results from the network or the repository data source that is more convenient. And then we dispatch this state, and the state flow handler is going to communicate the state to the imperative UI in order to render it. So that means actually the imperative and declarative UIs can coexist because we are making sure that everything is state managed. In that case, we can actually just change the imperative UI in order to manipulate that with a declarative UI. And with that, you can be ready to start integrating Jetpack Compose on Android. So now advantages of this approach of having everything with state management. For instance, flexibility, because we are making sure that both systems for UIs, both declarative and imperative, are being exchangeable with each other. So we can play with that as we go. Also, if we create a kind of layers composition instead over inheritance, then we can actually switch different elements, smaller entities with other entities, and then making a bigger system by using composition. So let's see some implementation details for my particular use case. So the data sources are the network and the DB, as you know. And then those are going to return these by means of suspend functions, one-shot operations again. And basically, this is composed by the Twitter API. If we think on Android, this is going to be just a retrofit client. And I'm going to check if there is any connection. I'm going to manipulate the responses and the request things that I need. And then I'm going to start using this method, that is the suspend function we were talking about, with an authenticated token. I will search for that query that the user is typing. And I will return this by means of either operator from the Aurora library, which basically in the left side has a throwable, that's an exception, anything that happened unexpectedly, or in the right side, some list of tweets that we want to pass to our UI. Either actually is very similar to Kotlin results, so basically the same, but either has more functionalities in the functional wall if you are interested in. Then, if we think in the database, I use room database, and what I have there is basically sending a list of tweets order by descending order in this case. And now let's see the repository. The repository has a suspend function and then manipulating that with flows, which what we can see here is that we are actually meeting different results with these flows. And the repository is going to be composed by a different set of entities, like the network data source that you are already familiar with, the different tables for my database, that's the tweet, the combination of the token and the query, and the tweets with the query that I was looking for, and something called task threading with just the different dispatchers. And I will return then, if I want to get this with the database, the flow with the list of tweets. Let's see a few cases that can happen to you when you are trying to make something like that. So for instance, this particular case, I started when I was starting to learn having this spam function, and inside I tried a flow. And I thought, well, that can be a good case just to try. Let's see what happens. Actually, this wouldn't even compile because a suspend function can only be with another suspend function inside it or into a coroutine context. And that means that you cannot really have a flow which is an open stream into a suspend function because it's a one-shot operation. That's not expected. That it wouldn't work. So better don't do that. And then another case that will success in our case is basically having a suspend function with retrieve all tweets. That is another suspend function returning a list of tweets in a one single operation. Basically something like that. Simple as that, and we have it. But now let's see other cases with flows. For instance, if we have the flow builder, we could emit all values for this open stream. And then this can be a very good case when we have a poll and we are basically updating every 30 seconds, let's say, from the network results, and then rendering this into the UI when it's refreshed. This can be a very good case for it. And then flow on operator is super handy because it's going to make sure that we are allocating this flow builder with anything in the input-output dispatcher. Then another case could be just emitting once and then having a suspend function inside that. But probably we don't want to do that because then better we have just a suspend function because it's one shot operation and we are wasting resources by using an emit and a flow when we can just have a spam function. Okay. Then finally, the case when we have the flow with two emissions, one with the previous results that we have in the DB before it was refreshed, and then the new results coming from the network when it's refreshed. So we emit it twice, and this is a very valid case. But now let's see the use case overview. So the use case, as you can remember, is basically the business logic layer. So basically transforming anything and then passing the results back. Then communicating this initially by means of callbacks. So basically the use case contains the repository and the coroutine scope that we are going to use. In this case, it's a retained scope for me, and this means that it's surviving configuration changes. So into that scope, basically I created this with the UI main thread of Android and a supervisor job. And let's see super quickly what we have for that. Basically to avoid side effects on cancellation. That's my use case. So basically the scope plus a supervisor job is going to make sure that we are avoiding other student cancellation when there is a problem. And if we see this in a diagram, it's as simple as if we cancel job 1, or basically there is an exception thrown in job 1 because something happened in the network and there is an exception, then maybe we don't want to cancel job 2 and 3. And then what we need is just to rely in the supervisor job, and then only when we cancel the further, then we will cancel all of them. But we don't want to have those side effects by canceling one of the jobs and then canceling the others as a side effect. But now let's see the use case implementation. Into the use case and the interface, I use my execute method with the query parameter and the callback initially, and then the cancellation method as well. The execute method has the query parameter and the callback. So basically the callback is going to show a loader initially. And then by scope is going to launch my coroutine. The repository will search the tweet with the query, will start mapping some operations, and the flow on by using this dispatcher. A computation dispatcher is basically default in dispatchers, is going to drop anything into this computation dispatcher, meaning also that the flow on, because it's upstream, is going to affect anything that is above it. So anything that we do into the map operator, it will be into the computation dispatcher. And then with catch operator, we can catch any substance that we have, like a try catch, and then collect will get any results and will pass it to the callback. Then something very similar, but maybe shorter, is basically the on each operator. That is equivalent to collect, but we don't have to do the launch, so the scope.launch. We have launch in with the scope, and behind the scenes, that's the same. The only difference is that because we have this catch that is below on each, because it's also upstream, it will catch any problem in the on each as well. And if we want to cancel the scope, then we can just invoke the method when we need it. But now let's see some synchronization with the UI. So yeah, we are going to deprecate the callback. We defined that it wasn't the best solution. So we're going to replace that with the state flows. I mean by that, the fact that we are going to remove the previous use case and we're going to create a new one that is going to be different to that. And we're going to define a new parameter as the generic one. We're going to remove the callbacks, and we are going to define a new method that is the get state flow, just to expose our state flow to the different stakeholders when they are going to need it. So basically, state flow is super interesting because it can be also passed across Java and Kotlin files. So that means that it's perfect for hybrid applications as well. So if we add, let's see, tweets UI state, for instance, then we can just expose it to different stakeholders. State flow is declared there, but the instance is created right here. So basically, I am creating a mutable state flow, and I'm gonna expose this by means of my function that is the public one. State flow is also using distinct until change, and that means that only when changes the state that we define is when it's gonna be emitted. If we have the previous state, because we have the buffer with the one only state, it wouldn't do any change to the chain that we have. And then the seal class that I define with that is the tweets UI state with a list of results UI state, and the tweets embedded into the first one, which is the list of results when we have a successful search. Also very important, we have to define everything when we define a seal class with the data classes with val. Why? Because first of all, Stateflow wouldn't differentiate with this thing that in chase that it has by default. Any difference, if you put bar, it would then be able to define that and distinguish that is read only. So you need to actually create your data classes with val all the time. Also good for recomposition, because otherwise the recomposition wouldn't do anything. The error UI state is going to define the message inside that. And the empty UI state gonna create the query inside that. So basically there is no result for this query. Loading UI state, basically just to indicate that we have to load some spinner. And the idle UI state, we need to define something at the very initial step. So to remove the callbacks, we just get rid of the callback right there. And in the flow, we have a very interesting operator that is on start, and it's convenient because it's actually more readable. We can understand here that the first thing is every time that we search for a tweet, we're gonna show the loading, and it's defining on start. In on each, every time that there is a result coming back, then we'll check, first of all, if the list of tweets is empty, then we'll show an empty UI state, or if it's not empty, then a list of results that are gonna count with the tweets. And we'll expose this state flow with dot value, as simple as that. We don't need anything else to send this to the different stakeholders. And the catch will also catch the different problems by emitting this error UI state with a message that we want to send to the user. So basically, that's how we pass state flow to our stakeholders, and in this case, to the state flow handler that's gonna be the one collecting it. So the presenter that I use has an activity scope that can be canceled. The search tweets basically gets the query. We remove any trace of the callback, and we're gonna just use the execute method as we did, but with less boilerplate code. And we're gonna expose the get state flow. And as you can see here, this is a Java file, and this actually properly passed the tweets UI state by means of the state flow. The view delegate is the one also sharing this state flow. And into my fragment, in this case, I'm gonna expose this get state flow that I'm gonna use into that. Basically, when I create the view, I'm gonna initialize my state flow and the different views. And this is what you can see here into my state handler. Initializing anything that I need, like the reference to the fragment in this case, state flow, and anything like that. Into there, I have the state flow, and I'm gonna collect actually by means of the on each functionality that is also valid in the state flow. And we could handle the different UI states right there. And we'll get this into a particular scope because it's a coroutine context, of course. So let's see some imperative stateful UI rendering. We are going to communicate the state by means of the state flow handler, and then rendering this into the imperative UI. And basically that means that we are handling those UI states and passing this in order to show some results. So the tweets that were passed from the tweets UI state gonna be rendered there. So let's see what we have in show results. So basically this extension function is hiding first of all the loading data. Now will become invisible. So that means we are changing the state of this particular UI element. Also hiding the error, we are also hiding that. And we are showing the recycle view with the different elements, the layout manager, the item decorator, and so on and so forth. And finally, we are going to update the adapter in order to show the different tweets. So basically the state flow will pass the list UI state with the tweets, and the tweets will be passed to the adapter that will correlate a tweet to a view holder and will render a particular item into that. And for the other methods, you can imagine, I won't dig into details, but we are showing the loader. So basically we are making the state visible for the load spinner, and then the others invisible, the same for the empty UI state, and the same for the error. Then for the idle UI state, I did nothing here. I didn't need it. So let's see some declarative stateless UI migration. Why stateless? Because declarative don't really care about state. So we are basically changing this rendering. So no more imperative UI for the rendering or the results, but declarative UI. So that means that I created a new entity called search composable UI. I pass the delegate, I pass the state handler, and then I'm gonna use basically this layout for interoperability purposes. So basically with the compose view that is provided by compose, I can start using it by this particular ID. For instance, I can just find this view by ID by getting the compose view, and then I can pass this to my entity and then playing with that, basically passing that as simple as that, and then getting this into that. So the fragment, we initialize the state flow as well, and then passing these composable UI, they're gonna be used into that. And into this handler, it is just the initialization, nothing really fancy here, and processing the different flows for collection. So basically, something very similar to before, where we're gonna start composing different views with the UI state that we are passing with this search state handler, and of course, the state flow. So the search composable UI has the compose view, and of course, we are starting to set the content. So basically, for compose, we're gonna need, of course, a first initial step. So when we do the set content, the first thing is a theme. Initially, by default, we have material theme, but you can define your own, that like I did here. This is actually super similar to a coroutine, because in a coroutine, you're gonna need a coroutine context first. That's the equivalent here with a theme. And what I mean by that you have here actually a composable, the first of them, but a composable can only be inside another composable or a theme. Likewise, a coroutine can only be into another suspend function or a coroutine context. But now let's see the state UI composable. This actually is defined with a set of different states, and we are starting to create a new one. Let's handle some alternatives and see what we can do there. So first of all, to reduce a little bit the amount of code, I removed this state flow handler and I just created a new UI state handler that's gonna do something similar but different at the same time. And I replaced that element with this another element into my view to collect the different things. And I just have this element right here. I don't need the other one. So I have only two entities. And I start composing the view by passing the compose view there and just passing the state flow. I don't need the reference to the fragment anymore. So here into the search UI state handler, I pass the compose view, I set the content, and I start with state UI. As you can see, I'm not passing here the state flow UI because it's already there. And then what I'm just using is the collect state convenient operator that state flow provides, that is actually retrieving a state that is ready for compose to be used. And then compose will understand that. And that means that every recomposition, we can rely into the value and see if there is a change. Now let's see what we can render for compose. For instance, state UI value basically gets the UI state, and the UI state, when changes, will have a new value with the tweets into that. And basically, I started the list results UI state with a tweet script. This is embedding a collection of tweets. So this collection of tweets, as you can see, is something as simple as that. It's a lazy vertical grid with different boxes, and those boxes are defined into the tweet box. And what I am doing there is just defining a set of two different columns, could be adaptative depending on the screen size, getting the content and the count of those tweets, and then passing the different tweets in order to pass this and also to pass that tweet into the click listener. And actually the click listener is as simple as that. It's just returning on a tweet click with a lambda. And this lambda gonna define basically the tweet that we need to pass with the title. And this will go to the tweet detail from that particular tweet when we are clicking. So basically we are passing this lambda right there with the on click, and we'll pass this lambda into the clickable function from the box. So anytime that we click, it will do the navigation to the next screen. Also, what I am defining here is a box with different elements. So the first element that we have to think about is column, if we are thinking in a vertical kind of alignment. And this is similar if we think in Android very old XMLs, not all, but we are still using it, linear layouts. So basically that's equivalent to columns. We just define a padding, we define that we want that space in between, and that we want to have this center horizontally. So that's all we need for that. And now we can start adding some different things, like an image at the top of it, where we can remember, let's say, the image URL for every recomposition to get only change when it's required. Because if after recomposition, the image URL didn't change, maybe you don't want to recycle this item because it's still on the screen. So for performance uses, it's better to have this remember for the next iteration after recomposition. Also, the image has a content description. That means that we have to define a particular thing for this image to be there. And this is important because we have to develop for everyone, and accessibility should be important for all of us. So please take this into account and try to avoid having this as a null or having this with quote quote, which doesn't give any value at all. Also, when we are starting to compose the different elements into composables, we could add a spacer like this one, and then we can start creating different texts with, in this case, a username. So that's basically how we, in a few lines, created this tweet box. Then for the other different elements, I reuse the center text. I just pass a query. We could use string resource if we have the resources into the XML file as usually we have, and then defining this for the different particular states that we have. Center text is something as simple as a text with the message, the padding, the material theme typography, an ellipsis, and some other parameters that you can dig into the documentation. Of course, the idle UI state, that basically for me is just a top text with a different alignment. That's why it's another one. Then finally, for the implementation, just cleaning up different resources, canceling the different scopes, nullifying the views, and those kind of things. You have obviously architecture components. Maybe you don't need to cancel the scope because you have different tooling that can do that for you. For the handler, destroying the different views and nullifying the different things. Same for the different views that we have there and the delegate and the cancellation for the different scopes that we have there. So with that, we have declarative ready with directional data flow. And this is the result, the final result. As you can see, start typing is the top text. I am starting to type different stuff. And by that, I'm gonna expect to see some, as you can see, grids with the different tweets. And when I am clicking some of those, it's going to the detail. So that's how I achieve that. Some lessons learned that for me are particularly the most important bit of this presentation. Interoperability. You already know what we can do with Compose View in our layouts. But on the other way, you also have Android View, which is basically the fact that you can, let's say, from a very old, super big XML, if you want to keep something, let's say you want to add into your new, actually it's for your new composable views, because if you have, let's say, a new screen, you want to build it with Compose, and you don't want to start from scratch an exo player or a super custom view with different stuff that costs you your life and you spend a lot of time and hours there. You can basically embed that, and then you have the same into the other wall. And now also super interesting because with abstract compose view, you could also add other elements in a way that is very easy to attach into an XML. The documentation is great, so go for it and have a look. Recomposition also runs multiple times, and that means that we have to be very mindful about how we handle our states and make sure that everything is inside a particular state. Because otherwise, if you want to render something, you will maybe have a mess with different things if you are relying in a particular order of rendering. So better to have everything that is belonging to a particular screen, coming from a state, and being able to respond to recomposition iterations. Also remember, we'll save a previous state in the view. That means something similar that you've seen so far with the view and the image. The fact that you can remember for a next iteration something. So that means that you, for instance, created a click, then you change a state by the click, and you want to keep this for the next iteration of the recomposition, then you will save this state. You will save this state for your next iteration to proceed from that particular point. Then another interesting concept is composition local. That means the simplest way to pass data flows to the tree and etc. And this basically means the fact that when you want to pass a value to a particular leaf or your tree, or the slot table, as we call to the hash table of Compose, then maybe you don't want to pass something from the theme to one of the trees by passing all the different fathers that are in the middle. So basically what you want to preferably do is using a composition local and then passing this to a particular leaf if it's only affected to this particular leaf or your tree. So that's why composition local is interesting to be used. Then composables should be also side effects free. And that means that we better be mindful about that as well, because you preferably don't want to have a network request after between our composition or our composition. So that means that there are something called effects handler that is handy for you to use after every recomposition, and you need to do a side effect. Also, Unidirectional Data Flows likes states, but really, really likes states. So that means that if we are trying to make something happening, we need to make sure that the different states are starting from a beginning and finishing to an end. And this should be also deterministic. Thinking in imperative against declarative programming, always we're gonna have this problem when we are to a new paradigm. So we are coming from this wonderful world where we are creating a big XML with a lot of things, and maybe we love to have 1,000 embedded XMLs. But now with declarative UIs, what we need to focus is in how is basically what we do and not how we do things, like imperative world. So basically, imperative means that you have to set your states and make sure that everything belongs with a different state. But with declarative, we need to focus in what we want to have, because either we have it or we don't have it on the screen. Just to recap, why compose is something that we should do, is something that we shouldn't do. Why is interesting? Compose runs every operation in parallel and very frequently. So that means that it's going to be really performant, and your screen is going to be very smoothly rendered by using Compose in the future if it's not already something that happens to you. Classic views rely on sequential order. So that means that you could actually make sure that something happens after something else happened. But this is something you cannot do with Compose. You either have something completed by a state, or you have a new state that's gonna be changed after something happens. So should rely in states basically. And then Compose is stateless. So that means that we need to rely in immutable data structures and things. And that means that everything gonna make it deterministic by default. However, the view is gonna be stateful, and that means that can be mutable and unpredictable. Why mutable? Because if we have a supermassive view, let's say with a big XML, a custom view inside that, then we have a different switches into that particular custom view. And then one of the switches says state, you need to handle this, and maybe you need to have a very complicated orchestrator or something like that in order to make that reliable. And that means that everything gonna mutate, and you are not going to have control of it. So that means that it's unpredictable because you don't have everything defined in one state. You're gonna have this defined in different subsets that are not really controlled by you. Then compose, you see it's being used in Kotlin and only in Kotlin. So that means if you want to use compose, you better have Kotlin ready into your files, or at least to collect different things and use different things with Kotlin. The classic views, however, can use Java and Kotlin file. Also, you have to think like classic views belong to the OS, to the Android OS. It's going to be very difficult for us to get rid of them. So in the end, we are going to need to collaborate together, both the classic and compose views. But if you prefer to be more pragmatic, maybe you want to go to compose in order to have things done quicker. Then compose is it means really is getting performance improvements a lot, because it's meant to have parallel execution of operations. That means that probably in the very future everything is going to be very smooth, and that's something that we all want, of course. Then the stability, because we are making everything ready to the states and their management. We are basically making sure that everything until we define a state is going to be testable, because we are proceeding to have a test for a validation of a management of this state. And by the time we are going to compose, this should be rendered depending on a UI state. So anything that's gonna be there for you is something that you define, and it shouldn't be any different. It's gonna be the thing that you define for this state. So that means that you can basically test this with espresso-like testing, or also screenshot kind of snapshot testing as well. Then reusability of UI components, because by using Compose, we can basically create very powerful and flexible UIs and can be reused everywhere very easily, and then with very fewer lines. And finally, experimentation of new ways of working, because can be done in a way that is very concise, means that if you want to define something by backend and you want to render something depending on what your backend says, you can very easily create UI-driven UIs by some backend. And next steps, basically starting explicit state declarations today. As you all probably know, we have a release candidate for Compose, and probably going to be stable very soon at the end of this month. So if we want to be all in the Compose party, probably we need to start adopting state declarations today, better than tomorrow. So that's all for today. I have different links and articles that you can read further if you want to dig into details. Also for Stateflow part 2 and the dependent article for Stateflow going to help you to understand that better. So this is going to be in the slides later on. Thanks to Nick Batcher for reviewing those slides back in January. Those got updated a few times already. And thank you for having me today. And if you have any questions, I can be more than happy to answer them.
Yes, thank you, Raúl, for the very exciting talk. Thank you for making the honor and sharing that in our user group. So if there are any questions, you can either write them in the chat or unmute yourself and ask them directly if you want. Okay, seems that nobody has any questions, so probably they did understand everything very good, or maybe are they too shy to unmute themselves or to ask a question. But either way, then I would thank you again. And I think we could close the meetup and hope to see you again in one of the next meetups. And of course, would be more than happy if Raúl, you could have next talks maybe next year or something, or this year too.
Thank you so much for having me today.
Thank you. You're welcome.
Thank you.